these guys. So this is also a review term, set of terms from geometry. We're going to get into some word problems with our right triangles now. And this has to do with angle of elevation and angle of depression. So this is going to help you draw and label the triangles when we get to those problems. So an angle of elevation is a line of sight looking out horizontal and a line of sight looking up at something. So let's call these guys Jack and Jill. Jack is looking up at Jill with an angle of elevation right there. So there's this horizontal and there's this line of sight. Jill at the top is looking down at him with an angle of depression. Again, that is an angle between a horizontal, that she looked directly out from the top of her little tower there, and then looking down at him. Okay, because both of these lines are horizontal, what relationship do they have to one another? They are parallel. Okay, so in this picture, I could label my little arrows. You guys remember doing that in geometry to show that those are parallel lines? So if you kind of pull out the picture, if you just look at the lines, what you have are horizontal lines cut by a transversal. That's a geometry set of information that you guys learned. And if we know that, horizontal lines cut by a transversal, you should then be able to tell me the relationship between the angle of elevation and angle of depression. How are they related? They are equal angles. So we can label those there and there. Do you remember what property from geometry that is? No. Starts with an A. That's it. They are alternate interior angles, which you don't need to know that for trigonometry, but that's why they are equal. When we have horizontal lines cut by a transversal, alternate interior angles are equal to each other. Okay, so why do we need to know that they're equal to each other? Because sometimes if we have an angle of depression, it might not necessarily be in our triangle, but we could label the angle of elevation instead, knowing that they're equal, or vice versa. All right, so for our next couple problems, we are going to draw the picture and solve for whatever's missing using our trig functions we learned about yesterday. When in doubt, everything right now is a right triangle. That is the only shape you should be drawing, is a right triangle, okay? So from an observation deck 425 feet high at the top of a lighthouse, the angle of depression to a ship at sea is 4.2 degrees. How many miles is the ship from a point at sea level to a point directly below the observation deck? Okay, so we're going to draw our picture first. We have a lighthouse, and we are going to assume that anything sticking out of the ground is making a 90-degree angle with the ground, unless it's like the Leaning Tower of Pisa, and they would tell you otherwise. Okay, so here's, I guess, the little island and the ocean. It is 425 feet high. That's my observation deck. And then at the top of my observation deck, I look down to a ship at sea. There's my ship. So there's my line of sight. There's my 90-degree angle, my lighthouse sticking out of the ground. And the angle of depression is 4.2 degrees. So remember, an angle of depression, imagine you're at the top of that lighthouse. You're looking out, you're looking down. The angle between those is 4.2 degrees. This is an example where that's not inside my triangle. So I'm going to instead label, or also label, the angle of elevation, which is, if you're in the boat, looking up instead. It's 4.2. We are solving for how many miles is the ship out to sea? So X at the bottom there. How far away are we from the lighthouse? All right, the angle that you know in your triangle is your theta. That's the angle of reference, and you can use whatever variable you want. We usually use theta. Then we're going to label any sides that we either know or are solving for. So 425 degree or feet, is that opposite, adjacent, or hypotenuse? It is opposite my theta. And then X we have to solve for. Is that opposite, adjacent, or hypotenuse? Adjacent. And then the other side's the hypotenuse, but we don't know it and we're not solving for it, so we don't even need to worry about it for this problem. If you have opposite and adjacent, which trig function is that? is tangent. So your two sides that you either know or are solving for are going to give away what trig function you're going to use to solve. So we're going to start with tangent. This is the TOA stuff. And then we always, next to our trig function, put the angle. In this case, we know the angle. It's 4.2 degrees. Equals our ratio. And this is where we put opposite over adjacent. 425 over 5. Okay, you're going to need your calculator to solve. To solve this, the first thing I'm going to do is multiply by x to get it out of the denominator. And then I'm going to divide by tangent 4.2 degrees. So 425 over tangent 4.2 degrees is what you're going to type in your calculator. Before you type it in your calculator, hit mode on your calculator and make sure you are in degree mode. We'll be going back and forth between degrees and radians. For right now, everything's going to be in degrees. So hit mode, make sure degrees highlighted, and then go ahead and type this in. And you should get, I'm going to give it one decimal place here, 5787.4 feet. Is that my final answer? No, it's not my final answer. What's the question asking for? I want it, the distance in miles, so what do I have to do? I have 5,787 feet. How could I convert that into miles? Yeah, divide by 5,280. And that'll turn it into miles. So it's going to be, I'm going to say approximately 1.1 miles. There's going to be our answer there. Any questions on that one? No? Okay, we're going to do one more word problem, just practice here. All right, from a point on the edge of two parallel rooftop sides, a point directly opposite is identified on another rooftop at an angle of 60 degrees. From a second point, 25 feet back from the first, a second siding is made, and that angle makes a 45-degree angle. How far apart are the two buildings? Okay, so the main reason we're doing this problem is it's kind of a tricky picture to draw to see the triangles. All right, so we have two buildings. And on the shorter building, somebody's looking up at the taller building. Okay. We're trying to figure out how far apart the buildings are. So ultimately, that's our x at the bottom there. All right, so it says from a point on the edge of one rooftop to the edge of the other, we can look up at the first siding with an angle of elevation of 60 degrees. So that angle of elevation is, we look out, we look up, 60 degrees between them. And I'm going to put a little right angle there. We have a horizontal. We're assuming the building is vertical, so we're going to say that those make a 90-degree angle with each other. Then the person on the smaller rooftop is going to walk back 25 feet. And they're going to look up again. And this time, excuse me, that angle of elevation is 45 degrees. We're going to use this information to figure out how far apart the buildings are from one another. Now that x, I can also put on the bottom of this triangle here. That's that same length. What I have right now, I think it would be easier if I put a little y there. We don't know what that side is, but it's a shared side. Do you guys see a triangle within a triangle in this picture? We have a little triangle and we have a big triangle. Okay, let's just focus on the little triangle. 60 degrees is my angle of reference. How are y and x related to 60? Y is the what side? Opposite, and X is adjacent. So what trig function could I write with the small triangle? Again, tangent. Okay, so that would look like tangent of 60 degrees equals y over x. Okay, and now we can do the same thing with the bigger triangle. I've got y, and then the bottom side is 25 plus x total if I put those together, but it's still opposite and adjacent. So tangent of 45 is opposite y, and this time the adjacent is 25 plus x. Now this looks a little nasty, but what we have is a system of equations here. The system of equations is two equations that share the same two variables, x and y, and we did those last semester. What we're going to use to solve this is substitution. We're going to get a variable alone, and in this case, it's actually very easy in both equations to get the y alone. I could say y equals x times tangent 60 for this equation, and I could say y equals 25 plus x tangent 45 in this equation if I multiply it by those denominators. And then because they're both equal to y, I can set them equal to each other. So my ultimate equation is going to be x tangent 60 equals 25 plus x tangent 45. Tangent 60 and tangent 45 are just numbers. You could at this point just type those in your calculator and see what they are equal to. Actually, these are ones that we did find yesterday. If you look back in your notes, does anybody remember what tangent 45 is equal to from yesterday? You can flip back if you want to. What's tangent 45? It's 1. Yeah, so 25 plus x times 1, this whole side is just 25 plus x. And then what's tangent 60 equal to from yesterday? Remember? It's got some radicals in it. We don't need the radical here. You can just type it in your calculator. The decimal approximation is about 1.73 x. It's radical 3 is where that number is coming from. Okay, so I have 1.73 x. And now you can see it just looks like a normal old equation. So I'm going to subtract 1x over from both sides, the 1x over there. So I'll have 0.73x equals 25, and then divide. And I'm going to get x equals 34.2 feet is the final answer. Okay, so this problem is interesting because it's kind of a lot of things that we've done all put together. I think the picture is probably the hardest thing to get at first, but after that, you can practice setting up your trig functions. You've got a little bit of a system of equation in there. You've got some of those new trig values showing up. I believe there is one of these on MathXL. You can use this one as an example when you're going through it. MathXL might solve this one a little more complicated than what you see here, so just fair warning if you use to help me solve this, that might not be helpful. Okay? Any questions on this problem? No? Okay, so the only other thing that we need to finish up from 5.2 that we didn't get to yesterday is we have in trigonometry, and we're going to do a lot of these in chapter 6, fundamental identities. Fundamental identities are relationships that have been proven to be true between our trigonometric functions. A couple of these we talked about yesterday already. We talked about that sine and cosecant were reciprocals, cosine and secant were reciprocals, tangent and cotangent are reciprocals. That's all of these reciprocal identities are saying. They're saying if I flip cosecant, I get sine. If I flip secant, I get cosine. If I flip cotangent, I get tangent. So it's just a fancy way of writing it. These other ones, if you take tangent, you're going to see that's the same if you divide sine over cosine. And if that's true, we know tangent and cotangent are reciprocals of each other. So cotangent then is cosine over sine. In algebra 2, do you guys remember this one on the top here? The Pythagorean identity? gets its name because it looks like the Pythagorean theorem. You can use right triangles to prove it. When you see a trig function squared like that, that actually means this. Like if you were going to type that in your calculator, you would type it in like that. The reason we don't write it like that, well, there's actually two reasons we never write it like this. The first reason we don't write it like that is because if there's not a parentheses there, it looks like the angle is squared and not the trig function. The second reason we don't write it like this is because it's super tedious. We're going to see that we're going to write a lot of trig functions that are squared, and if I have to put parentheses around it every time, it's going to take forever. So instead, somebody just decided this is a whole lot easier. It's obvious that the trig function is squared, and I don't have to put parentheses there every single time. So that's how we're always going to write it. But know that if you typed it in your calculator, you would do it like that. Okay, once we have sine squared plus cosine squared equals 1, we can actually take those, and we'll prove these other guys later, and get 1 plus tangent squared is equal to secant squared, 1 plus cotangent squared is equal to cosecant squared. Okay, so those are called Pythagorean identities, all the ones that are squared. Quotient identities are the ones where we divide one over another. And then on the next slide, this is the last group that we talk about in chapter 5. These are called co-function identities, and we actually saw this pop up a little bit yesterday with those 30, 60, 90 triangles. If you look back at your notes, you would see that sine of 30 degrees is equal to cosine of 60 degrees. That is actually because of the co-function identities. Co-function identities say we've got pairs. Now these aren't reciprocal pairs. You can see sine and cosine go together, tangent and cotangent go together, and secant and cosecant go together. I think they're called co-function pairs because they have the word co in front of them. Sine, cosine, tangent, cotangent, secant, cosecant. Okay, so that's how you can remember which ones go together. All these angles are saying is that the two angles that you can plug in must be complementary angles, like 30 and 60 add to 90, or I could make it 20 and 70. As long as I have co-function pairs and complementary angles that I plug in, the equation is true. We don't do a ton with this. You can see the example at the bottom. It's going to be very quick and easy. It says, given that cosecant 21 is approximately that number, find the secant of 69 degrees. All they want you to do here is recognize a couple things. First of all, we have cosecant and secant. Cosecant and secant. Secant and cosecant, right? There's a co-function pair. And then we have two angles, 21 and 69. What do those add to? They add to 90. So we should be able to say, okay, those two guys that I have must be equal to each other based on these properties. And if one of them equals 2.7904, the other one also equals 2.7904. So that's our answer. They're just asking you to recognize that you see that those would be equal because they're a special pair and a special set of angles. Okay? So the last thing we're going to do is practice simplifying with these identities. We're going to start using the identities. If a problem on Math Excel says use identities to find, I would highly recommend that you practice doing it that way. You can also use triangles to find the information, but on a test or quiz, if it says use an identity and you use a triangle, you will not get any credit for the problem, okay? And that's especially going to be true in Chapter 6 when we won't have any numbers anymore and you won't be able to use a triangle. So it's good to practice with it, but I'll show you how we can simplify with the identities and then check it with a triangle. Okay, so you're going to see some problems like this. It says, let theta be an acute angle where cosine of theta is 1 over rad 3. Find the following using identities. Okay, I have a cosine, and we're going to do these in order. The first thing I want to find is a sine. So here's how we use identities to do that. We want to find one formula that includes a sine and a cosine, and only a sine and a cosine. So like I don't want the quotient identity because that has a tangent in it too. So if I look back and I want one formula that just has sine and cosine, I'm looking at that first Pythagorean identity. If I can plug in one, I can solve for the other. So that's what we're going to do. All right, so I'm going to use sine squared plus cosine squared equals 1. And sine squared I don't know, but my cosine I do know. My cosine is 1 over rad 3. Remember, that is not an angle, that is the whole cosine. So the cosine and the theta disappear. Just don't forget that it's squared still. Then we're going to square the numerator and denominator. Sine squared plus 1 squared on top is just 1. Rad 3 squared is 3. So 1/3 equals 1. Solve for sine. So if I subtract 1/3, I'm going to get sine squared is equal to 2/3. And then I need to take the square root. We're not worried about a plus or minus right now. We're just going to say everything's positive. If I want to square root that, I can just square root the numerator and denominator separately. And then review from yesterday. I don't want that radical in the bottom, so I'm going to multiply the top and the bottom, both by square root 3. A radical times itself on the bottom just gives me 3. On top, the square root of 2 times the square root of 3 gives me the square root of 6. You cannot reduce those. One is in a radical, the other is not. Leave it. Okay, remember, we're not solving for an angle, we're just solving for the value of sine, which we have. We're done. Okay, so that's using one trig function to get another. All right, the next thing I need, now I have like more in my toolbox. I have cosine and I have sine. The next thing I need is cosecant. So now you can find a property that involves sine and cosecant, or a property that involves cosine and cosecant. If I were doing this, the easiest properties to use out of all of these are the reciprocals, because all I have to do is flip something, right? I have sine, and I'm looking for cosecant. Aren't those reciprocals of each other? So all I have to do, if I have sine and I want cosecant, is take my sine and flip it. Now remember, we talked about this yesterday. You have a couple options that you can flip. In both of those, I'm going to end up with a radical in the denominator. But in the second one, my numbers are bigger, which means likely I'm going to have to reduce if I use that one. So I'm going to flip the rad 2 over the rad 3. I'm going to make it rad 3 over rad 2. And then I'm just going to rationalize. Times rad 2 over rad 2. I end up with rad 6 over 2. Okay. If you flip the other one, it's fine. You would just have some bigger numbers and you'd have to reduce your fraction at the end. Just adds an extra step. Okay, so now I have cosine, sine, and cosecant. I want to find tangent. Okay, well, we used a reciprocal identity. We used a quotient identity. Or what else do we use? A Pythagorean identity. Let's use a quotient identity because we haven't used that yet. Quotient identities, if I want to find tangent, I would do sine over cosine. Okay, and we have sine and we have cosine. So let's plug them in. Sine is rad 6 over 3, and cosine is rad 6 over 2. Instead of dividing by a fraction, what can you multiply by? Instead of dividing by a fraction, we can multiply by the... Go ahead. Oh, I did. Oh, gosh. Thank you. Better. Okay. All right. Instead of dividing by a fraction, I can multiply by the reciprocal. So instead of dividing by 1 over rad 3, I can just multiply by rad 3 over 1. That's going to give me rad 18 over 3. Does that simplify? Square root 18 breaks down to what? 9 and 2, so 3 rad 2 over 3, or rad 2. Okay, so first one we used Pythagorean, second one we did reciprocal, third one we did quotient, just to give you an example what each of those would look like. The fourth and final one is the most obvious which group of identities you're going to use because it has a 90 minus in it. If there's a 90 minus in it, you are using the co-function identities, that group. If you look at the co-function identities, secant and cosecant are a pair. One angle is 90 minus theta, the other angle is just theta. So this is saying that I'm trying to find is equal to cosecant theta. And didn't we already find that? It was rad 6 over 2. That's it. Okay. Now, here's how you can check this. And quite honestly, the check is easier than the rest of the problem. If I have a right triangle and I know the cosine, here's my theta. The adjacent side is 1 and the hypotenuse is rad 3. If you do the Pythagorean theorem, you're going to get rad 2 for the opposite side. And then if I want sine, I can do opposite over hypotenuse, rad 2 over rad 3. If I want cosecant, I can do hypotenuse over opposite. If I want tangent, I can do opposite over adjacent. I can check all of these answers very quickly, but it's not using an identity. Okay, so be cautious using the triangles because when we get a little further along, there won't be numbers anymore, which means you can't use a triangle. There will only be identities to use. So that's the goal right now, is just to get you familiar with them, because in chapter 6, the numbers are disappearing. Okay? Yes? 5. We do in this class 5, 6, and 7. That's it. 3 tests. Yes, sir. All right, last problem of the day is yours to try. Similar to the last one, if you want to check it when you're done early, you can draw a triangle. This one's a little easier than the last one because there won't be any radicals. It'll be all nice, pretty whole numbers, so there won't be any rationalized for you. Okay? See what you can do. You're given sign, use identities to find the other functions. You can work together. Yep, go ahead. Absolutely. All right, let's check our answers. And I drew the triangle at the bottom there if you want to check the triangle. Joe, look who I just found.
Oh, hi. She just signed my paper.
Oh, that's a 4/3 at the bottom, guys. Okay, so the first one I used a Pythagorean identity, the second one I used a reciprocal, third one I used a quotient, and then the last one, just finding what that's equal to, which is a tangent, which gives you that 4/3. And if you want to check any of your ratios, you can use the triangle to do it. Okay, remember the triangle is easier. If the instructions don't say use an identity, draw the triangle and just do it that way.
For sure.
Yes.
Do you have to memorize all of those identities?
Yeah, you do. So for this test, I don't think you're going to need them really, except maybe the reciprocal identities. For chapter 6, there's going to be about 40 of them. Not this current chapter.
What day was that?
Don't worry, there'll be Quizlet, and there'll be a whole test of you just filling out identities.
Yeah, the 7th, yeah.
How long were you there?
5 hours.
That's a big
Okay.
number.
All right, just memorize.
No math.
No math.
Oh,
I'm
that's
going to give you that formula, and you fill in the other half. Okay, so that's like a ways away. That's like in March. We got time.
But you know what? You should start memorizing some of them now.
These are the easy ones. So,
Is it more?
well, there's about, like I said,
It's a sheet like this.
40 some of them. Yeah,
It's
it's
a
a
fold
whole sheet.
Oh, I remember something.
We'll get there, don't worry. That's a March problem. That's not a January problem.
Oh, you know, I love science. I see that all the time.
All right, guys, you got 10 minutes. Last part of the period yours. You can get started on your 5-2 Math Excel. Remember, Math Excel is due on Thursday night this week. All right, so do a little bit tonight. You can ask questions in class tomorrow. Finish it up tomorrow.
Put this back up here.
They look great.
So
So great.
I think so.
Could you make